Welcome. Today, we'll dive into the device settings in TonCut, covering key configurations for both 1D and 2D devices to help you optimize your cutting processes effectively. TonCut supports two device types, 1D devices and 2D devices. For each type, you'll want to select the appropriate material type to ensure accurate optimization settings. At the top, you'll notice the driver field, which is common to both 1D and 2D devices. For now, simply set this to Other. We'll cover the specific driver options in a separate video, where we'll explain how different drivers interact with TonCut for various cutting devices. When setting up a 1D device, you'll first select 1D as the material type. Then, you'll configure several options, starting with miter cuts. Here, you can specify how the miter cut should be determined on both the left and right sides, with various positioning options to match the capabilities of your device. Next, let's define the minimum cut width. This setting specifies the minimum distance required between two cuts. For instance, if you set this to 10 millimeters, two cuts can't be placed closer than 10 millimeters apart. This setting helps prevent overlapping cuts and ensures safe spacing, especially for devices that might have cutting blade limitations. Moving on to formatting options for 1D devices, you have two choices. The optimal option minimizes waste by trimming only the necessary material for formatting, leaving a larger, reusable waste piece at the end. The first both edges method removes the formatting material from both the left and right edges at the start, without focusing on waste optimization. For 2D devices, there are additional settings to consider. You'll have the option to allow crossing cuts, which permits two cuts to intersect within the material. If crossing cuts are disallowed, cuts do not necessarily have to be edge-to-edge. You can turn off both crossing cuts and edge-to-edge cuts independently. When cuts only from edge to edge is selected, each cut must run continuously from one edge of the material to the opposite edge without stopping in the middle. Another option is strip cutting, which is useful for any device that cuts in strips, such as panel saws. This allows you to specify whether to cut strips along the material's length or width, depending on your needs. The minimum cut width setting for 2D devices also has a specific use for materials like glass. When cutting glass, a diamond knife scores the surface, and the glass is then broken along the scored line. However, breaking the glass cleanly requires enough width on both sides of the cut. Setting a minimum cut width, say 15 millimeters, ensures there is adequate space on each side of the cut, facilitating a clean break without risking unintentional cracking or failure to separate. The cut depth limit setting specifies the maximum depth level the device can support. Each depth level represents a sequence of cuts, where deeper levels involve cuts within previously cut sections. For example, in a layout with multiple depth levels, the first depth level includes initial cuts that divide the material into larger sections, while subsequent depth levels further divide these sections into smaller pieces. Setting a cut depth limit helps control the complexity of the cutting process, ensuring the device doesn't attempt cuts beyond its capability. You can further refine your cuts with the cut length limit setting, primarily for guillotine-style cutters. If your device has a maximum cutting length, say 1 meter, this setting ensures that TonCut won't generate cuts longer than that limit, preserving compatibility with your equipment. You can apply this limit to either the length or width, or both, based on your setup. Now, let's go over the formatting methods for 2D devices. These methods control the order in which edges are trimmed to prepare the stock for cutting while minimizing waste or focusing on specific edge priorities. Optimal. This method focuses on minimizing waste by trimming only the necessary material. It results in a larger, reusable waste piece at one end of the stock, rather than removing material from all edges. This method is ideal when you want to maximize the amount of usable material. Less cuts along length first. In this method, the horizontal edges, the top and bottom, are trimmed first, followed by the vertical edges, the left and right. This approach may be useful when you want to clear the horizontal edges initially before handling the vertical cuts. Less cuts along width first. This method prioritizes trimming the vertical edges, the left and right, before the horizontal edges. It's useful when you need to address the vertical edges first, which may be helpful in certain workflows or with specific types of stock. In addition to these formatting methods, there's an independent option: formatting of left and top edge with 2 full cuts. This setting can be enabled alongside any formatting method and prioritizes initial full cuts along the left and top edges. It's helpful in workflows where these edges need precise, full-length trimming at the beginning of the process. With these device settings and tips, you're now prepared to configure your cutting devices in TonCut to maximize efficiency and minimize waste. Thanks for watching, and see you in the next video.